Welcome to relative, extrema, and critical values. So we have a new word here, critical values. So a critical value of function f is an x value where either f prime of x is equal to 0 or f prime of x is undefined. And then we have a critical point is the corresponding point x comma f of x. So let's go ahead and consider the function f of x equals 1/3 x cubed minus 4x squared minus 9x plus 5. So our job is to find all critical values. Now the very first thing we should do is we should find f prime of x. So using the power rule, we know that f prime of x would be equal to 1/3 times 3x squared, or simply x squared, and then minus 4 times 2x, or minus 8x, and then we would just have minus 9. Then we want to find all places where f prime of x is either undefined or equal to 0. So find all x values for which, whoops, forgot my h, for which f prime of x equals 0 or is undefined. So we know that polynomials are not undefined everywhere. So in this case, this will be never. And then for f prime of x equaling 0, we're looking for where does x squared minus 8x minus 9 equals 0. This factors as x minus 9, x plus 1. So we have either x minus 9 equals 0 or x plus 1 equals 0. And we got x equals 9 or negative 1. So our critical values in this case would be x equals negative 1 or 9. Let's do one more function. Let's consider the function g of x equals x squared minus 5x plus 1 if x is less than or equal to 3, and negative 3x plus 4 for x greater than 3. So we do have a piecewise function. I'm just going to check for continuity first at x equals 3. We're going to check for continuity first. both pieces are polynomials, so the only point of interest would be at the break, so at x equals 3. So let's do the limit as x approaches 3 from the left of g of x would be the limit as x approaches 3 from the left of x squared minus 5x plus 1. And we can go ahead and plug 3 in. We have 3 squared minus 5 times 3 plus 1, or negative 5. And then this is also equal to g of 3. And then the last step would be if we do the limit as x approaches 3 from the right of g of x. We're looking at the limit as x approaches 3 from the right of negative 3x plus 4. So we have negative 3 times 3 plus 4, which is again negative 5. So all of these match. So we do have continuity. And now we're going to go ahead and check the derivative and look for any critical values. So I'm going to just give myself a little more space quickly. So next up, we're going to find g prime. So recall that g of x is equal to x squared minus 5x plus 1 for x less than or equal to 3, and then negative 3x plus 4 for x greater than 3. When we take the derivative, we can take each of these on their own. So g prime of x would be 2x minus 5. I'm going to just do x less than 3 for right now. And then negative 3 for x greater than 3. The reason why I switched to less than instead of less than or equal to is the derivative requires taking a limit from both sides. And so unless these two agree, then we won't have that it's differentiable at x equals 3. So now we're going to find where g prime of x equals 0 or is undefined. So for g prime of x equaling 0, for x less than 3, we're going to look at 2x minus 5 equals 0. And that winds up being x is equal to 5/2 or 2.5. For x greater than 3, it's never 0. If we want to look where g prime of x is undefined, we're going to check at x equals 3. So if we plug in for the left side, if we look at the limit as x goes to 3 from the left of g prime of x, then we'd be looking at the limit as x goes to 3 from the left of 2x minus 5 And if we plug in our 3, 2 times 3 minus 5, we wind up getting 1. Versus if we look from the right, this problem's taking a lot more space than I thought. Okay. If we look from the right, we take the limit as x approaches 3 from the right of g prime of x. We have the limit as x approaches 3 from the right of -3. This is -3. So since these don't match, we wind up getting that g prime of 3 is undefined. And so our points of interest, we wind up getting our critical values. Of, we had x equaling 2.5 was a point of interest, and 3 is also a point of interest. So last up, we have a theorem, and I kind of hinted at this in the last video. It turns out that our relative extrema can only take place at a critical value. So relative extrema of the function f can only occur at critical values. So a relative extrema require the function to turn around. So either it's got a smooth turn, in which case the derivative would be 0, or it's got a sharp turn, and then we would have an undefined derivative. So again, the function must turn around. If we have a smooth turn, then that's a f prime of x equaling 0. And if we have a sharp turn, then that's an f prime of x is undefined. Note this does not go the opposite direction. So relative extrema can only occur at critical values, but it is not necessarily true that a critical value has to give us a relative extrema. So quick warning, not all critical values give relative extrema. So, but the main thing we do have is that if we are looking for relative extrema, we can narrow down where they might occur by looking for our critical values.